mass, written as m, times its velocity, which is written as v. P equals mv. That's the equation. And you immediately see the problem. Well, a photon of light travels at the speed of light, which is written as c, by the way. Its mass is 0. And 0 times the number is 0. So the momentum of a photon should be 0, right? I mean, that's a really good question. Yet physicists are certain that photons have momentum. So let me start with explaining this in terms of equations, then go to a more intuitive explanation, although even that's really not all that intuitive. It's going to be pretty cool, but you should expect that your brain cells are going to get a real serious workout here. First, let me remind you of the equations that you would have encountered in any introductory physics class. I already reminded you of the momentum one. There's also another equation that connects mass, velocity, and kinetic energy. This is kinetic energy, which is written as Ke, equals 1/2 times the mass, m, times the velocity, v squared. So we say that Ke equals 1/2 mv squared. You probably remember all that. Now let me show you how kinetic energy and momentum are related. Let's start with the momentum equation, P equals mv. Now square both sides. You get P squared equals m squared v squared. So far so good, right? Now divide both sides by m. On the right-hand side, the bottom m cancels one of the top m's, and you get P squared divided by m equals mv squared, which should remind you of something, specifically the kinetic energy equation. You can replace the m times v squared in the kinetic energy equation with this P squared over m thing. And what you find is that the kinetic energy equals the momentum squared divided by twice the mass. Ke equals P squared divided by 2m. Okay, the first conclusion to draw here is that in classical physics, and I remind you that these equations were devised back in Newton's time when they didn't worry about things moving near the speed of light. But even back then, we can see that kinetic energy and momentum are related. We have an equation with energy on one side and momentum on the other. And this kind of means that anything with kinetic energy must also have momentum. Of course, we still have that m kicking around, which is 0 for photons, so I haven't really answered the question. I didn't intend to at this point. I just wanted to show you that kinetic energy and momentum are related, even classically. Okay, now to get into something you might not have known. Let's move into this new material. And I want to tell you something, and that is that these equations aren't completely true. That's right, you've been lied to. Wake up, sheeple. The man is lying to you. Man, I have always wanted to say that in the video. Why should others have all the fun? Of course, like a lot of times when people toss around the word sheeple, what I just said was a little misleading, and the real story is a bit complicated. The real truth is that those equations are special cases that only work for objects with mass that is moving at slow speeds. And of course, I should be upfront that when I say the man is someone like me, so I guess you have to decide whether to believe me or not, but you should, because, I know stuff, and it's way cool. Now comes the next surprise, and that surprise involves Einstein. Of course, Einstein was all about moving at super fast speeds near the speed of light, so you know that he's going to pop up in any discussion involving photons and momentum. And when you think about Einstein, you almost always think about his famous equation, E equals mc squared. And guess what? That equation's wrong too. Come on, sheeple, wake up! How long are you going to stay fooled? Okay, I promise, that's the last rant. But the rant is a super tiny kernel of truth. E equals mc squared is also an approximate equation, and one that only works for objects with mass that are stationary. It's not a general equation, and it doesn't work for massless objects, nor objects that are moving. In fact, I made a whole video just digging into the limitations of this equation. The link is down there in the description. Watch it later if you're interested. So now we're ready to get to the truth. I put the three equations I mentioned so far here. E equals mc squared, P equals mv, and Ke equals P squared divided by 2m. And all of these equations are just fine and correct, but they are all equations that only describe objects with mass that move slowly. Those equations fail in other situations. It turns out that there is a more general equation that works for all situations, and it looks kind of like Einstein's famous equation. A super common question is, how can a photon, which has no mass, have momentum? That's a good question with a lot of complexity in the answer, so let's dive into it. The reason that people ask the question of how photons can have momentum is that they learned about momentum in a physics class, and they learned the equation for momentum. So I have to build the explanation around that equation. This equation says that momentum, which is written as p, is equal to an object's mass, written as m, times its velocity, which is written as v. P equals mv. That's the equation. And you immediately see the problem. Well, a photon of light travels at the speed of light, which is written as c, by the way. Its mass is 0. And 0 times the number is 0. So the momentum of a photon should be 0, right? I mean, that's a really good question. Yet physicists are certain that photons have momentum. So let me start with explaining this in terms of equations, then go to a more intuitive explanation, although even that's really not all that intuitive. It's going to be pretty cool, but you should expect that your brain cells are going to get a real serious workout here. First, let me remind you of the equations that you would have encountered in any introductory physics class. I already reminded you of the momentum one. There's also another equation that connects mass, velocity, and kinetic energy. This is kinetic energy, which is written as Ke, equals 1/2 times the mass